In the vast expanse of our solar system, one celestial body reigns supreme: the Sun. Its fiery brilliance outshines every other object in our solar neighborhood, and it's hard to ignore its dominance. The Sun, a massive ball of glowing gas, is the epicenter of our solar system, the gravitational titan keeping all the planets in their orbits. This self-luminous celestial body is the ultimate source of light and warmth, making life as we know it possible on our little blue planet Earth. But the Sun is not just a monolithic light bulb in the sky. It is a dynamic and ever-changing entity, a sizzling sphere of hot plasma interwoven with magnetic fields. From its radiant surface, the Sun emits a ceaseless stream of photons, tiny particles of light that race across the solar system. These photons, after a journey of about 8.5 minutes, reach Earth, bathing it in daylight. They warm our planet, drive our weather, and provide the energy for photosynthesis, the process by which plants produce food. But the Sun's influence extends beyond its light and warmth. It also emits a steady stream of particles known as the solar wind, which can create stunning auroras when they interact with Earth's magnetic field. And let's not forget the Sun's more dramatic side. Its surface is often marred by dark sunspots, and it periodically unleashes enormous flares and coronal mass ejections, powerful explosions that send a torrent of solar material hurtling into space. From our vantage point here on Earth, we can only see so much of the Sun. That's where space probes and satellites come in. These robotic explorers give us a front-row seat to the Sun's splendor and volatility, allowing us to study its complex dynamics in detail. Our journey to explore the majestic Sun begins here. As we delve deeper into the workings of our nearest star, we will uncover the profound mysteries it holds and the crucial role it plays in our lives and the wider cosmos. So let's set off on this journey together towards the heart of our solar system. At the heart of the Sun lies a fiery inferno, a place of unimaginable energy. This energy is forged in a process that is both simple and complex, as ancient as the universe itself: nuclear fusion. In this searing crucible over 15 million degrees Celsius, 4 hydrogen nuclei combine to form a single helium nucleus. But this transformation is not without its cost. In the process, a small amount of matter is lost, converted into pure energy following Einstein's famous equation, E equals mc squared. It is this energy, this radiant light, that fuels the Sun and bathes our solar system in life-sustaining warmth. But what happens to this newly formed helium nucleus, you might ask? Well, it's a bit of a wanderer. It embarks on a slow million-year journey from the Sun's core to its surface, bouncing around like a pinball in the Sun's dense interior. Along the way, it shares its energy with the surrounding plasma, keeping the Sun's outer layers hot and bright. This nuclear fusion, this alchemy of the Sun, doesn't just happen anywhere. It requires extreme pressure and temperature, conditions found only in the Sun's core. This is where the Sun's colossal gravitational force compresses the hydrogen gas, creating the perfect fusion furnace. Yet, despite its intensity, the Sun's core is not a chaotic place. It is a realm of balance, where the inward pull of gravity is perfectly matched by the outward push of pressure from the fusion reactions. This delicate equilibrium allows the Sun to shine steadily, providing the constant light and warmth that life on Earth depends on. This fiery core is the powerhouse of the Sun. It's the engine that drives the Sun's vast output of energy, the heart that beats within our star. Every beam of sunlight, every warmth-filled day, every life on Earth owes its existence to this cosmic crucible. It's a testament to the incredible power of the universe, a power that reaches out across the void, touches us and binds us all in a dance of light and life. Let's hear from the experts, the solar physicists, about the Sun's dynamic character. Solar Physicist 1. The Sun, it's not just a bright disk in the sky. It's a tremendously energetic and complex system, constantly changing and evolving. Its importance can't be overstated. It's the source of light and heat, without which life as we know it wouldn't exist. Solar Physicist 2. That's right. And the Sun also has a dynamic personality, so to speak. It's not static. It goes through cycles, has mood swings, if you will. Sunspots, solar flares, coronal mass ejections. These are all manifestations of the Sun's activity, which we study to understand the star better. Solar Physicist 3. And there's a practical aspect to this research. Solar storms, for instance, can disrupt satellite communications, affecting everything from your GPS signal to your favorite TV show. They can even cause power outages. So, understanding the sun is not just about satisfying our curiosity, it's about predicting and mitigating these effects. Solar Physicist 4. Yes, it's fascinating. We use a range of tools to study the sun, from ground-based observatories to space-based telescopes. Each of these gives us a different perspective, a different piece of the puzzle. And the more pieces we have, the more complete our understanding of the sun becomes. Solar Physicist 5. One of the most exciting aspects of solar physics is the ability to actually see these phenomena happening. To watch a solar flare erupt or a sunspot forming, it's just mind-boggling. And it's a reminder of the incredible forces at work in our universe. Solar Physicist 6, and let's not forget that the sun is just one star among billions in our galaxy, which is itself one among billions of galaxies. Studying the sun helps us understand other stars, other solar systems, and ultimately the universe itself. The sun, a dynamic and ever-changing celestial object, has much to teach us. To study the sun, scientists use a variety of sophisticated instruments. Each of these tools plays a crucial role in peeling back the layers of our nearest star, revealing its secrets, and helping us understand its influence on our planet. First, let's talk about ground-based telescopes. These are often housed in solar observatories, places specially designed to study the sun. These telescopes can observe the sun in incredible detail, helping us understand phenomena like sunspots and solar flares. Some even use a method called spectroscopy, which allows scientists to determine the sun's chemical composition and temperature. But what about when we need to get a closer look? That's where space-based satellites come in. These incredible machines orbit the Earth, capturing images and data from a vantage point unobstructed by our planet's atmosphere. One such satellite is the Solar Dynamics Observatory, or SDO. The SDO observes the sun around the clock, capturing high-resolution images and helping us understand the sun's magnetic field. Then there's the Parker Solar Probe, a spacecraft that's doing something truly remarkable. It's flying closer to the sun than any mission before it, gathering data on the sun's atmosphere, or corona. The information it collects could help us predict solar storms and better protect our technology and astronauts from the sun's intense radiation. Finally, let's not forget about the solar radio observatories. These facilities observe the sun at radio wavelengths, revealing information about the sun's outer atmosphere and the solar wind, a stream of charged particles that the sun constantly emits into space. These tools, along with many others, work together to give us a comprehensive view of the sun. They help us understand its behavior, predict its changes, and learn about its impact on our planet. These tools provide us with a deeper understanding of our nearest star. As we continue to study the sun, we can only imagine what new discoveries await us in the celestial dance of our solar system. The sun's activity influences our planet in more ways than one might think. Our nearest star doesn't merely provide us with light and warmth, it also plays a massive part in shaping the space weather around Earth. Every moment, the sun is releasing a stream of charged particles known as the solar wind. During periods of intense solar activity, this wind can become a storm, capable of causing disruptions right here on our home planet. Satellite communications, which we rely on for everything from weather forecasting to GPS navigation, are particularly vulnerable to these solar storms. Even our electricity networks aren't safe. High-energy particles can induce currents in power lines, potentially leading to widespread blackouts. But it's not all doom and gloom. The same solar particles that can cause havoc with our technology also create one of nature's most stunning displays: the auroras. These dazzling light shows are a direct result of solar particles interacting with Earth's magnetic field. The sun's influence reaches far beyond its light and warmth. Throughout history, civilizations have revered and feared the sun. It's been a central figure in mythology, a divine entity in many cultures, an object of worship, and a symbol of life and power. It has inspired art, literature, and music, casting its golden radiance on every facet of human expression. From the ancient Egyptians who worshipped Ra, the sun god, to the Aztecs who believed the sun and earth were intrinsically linked, the sun has been a cornerstone of cultural identity. It's been a calendar, marking time and seasons, guiding agriculture and harvests. Solar eclipses, too, have played an influential role in history. These celestial events have been seen as omens, causing fear and awe, influencing decisions of war and peace, and leading to profound societal changes. The sun's cultural significance is as profound as its physical presence in our sky. It is not just a star, it's a symbol, a guide, a god, and a muse. It's a testament to how deeply our lives are intertwined with the cosmos.